Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about Part 1. Design of reinforced concrete cement. Question and answer. 1. Define reinforced concrete. Reinforced cement concrete is a composite material is made of concrete and steel reinforcement. The concrete may be assumed to work purely in compression, whereas the reinforcement is predominantly subjected to tension. For a large range of applications it is sufficient to consider the uni-axial response of either material. 2. What are the advantages of RCC when compared with other building materials? Concrete is workable when fresh and strong when hardens. It can be molded into any required shape and size. The raw materials required are easily available. Skill is not required for casting concrete elements. Concrete is durable, fire-resisting and rigid. Concrete requires less maintenance. 3. What are the disadvantages of RCC when compared with other building materials? The self-weight of the structural elements will be more while concrete is used. Concrete has a very low tensile strength. Hence cracks will form in the tension zone if reinforcement is not provided properly. Cracks develop in concrete, also due to shrinkage, creep, temperature, etc., which permit seepage of water into the concrete. This causes corrosion of steel reinforcement and thereby peeling of concrete. Concrete has poor insulating property. Dismantling and reusing of concrete elements are mostly not possible. Concrete is brittle in nature and hence has low impact resisting capacity. 4. What is the purpose of using reinforced cement concrete? Plain cement concrete has very low tensile strength. The tensile strength of concrete is about 1/10 of its compressive strength. As a result, a plain concrete beam fails suddenly as soon as the tension cracks start to develop. To improve the tensile strength of concrete, some sort of reinforcement is needed which can take up the tensile stress developed in the structure. It not only increases the strength but also in preventing the temperature and shrinkage. Therefore, reinforcing steel is added in the tension zone to carry all the developed tensile stresses. 5. What are the uses of reinforced concrete? It is used for the construction of buildings, bunkers and silos, chimneys and towers, flyovers, retaining walls, roads and railway bridges, water tanks. 6. What are the types of load on R.C. structures? Dead load, live load or imposed load, wind load, snow load, earthquake load, seismic load. 7. What are the elements of structures? Beam, column, floor, foundation, slab, staircase. 8. What are the methods of design? Modular ratio method, or working stress method, WSM, or elastic method of design. Load factor method, or ultimate load method, ULM, or ultimate strength method. Limit state method, LSM. 9. Define elastic method of design. The elastic method of design of reinforced concrete member is also known as working stress method, or modular ratio method. Elastic behaviors of materials are used in elastic method of design. The method of elastic design of a structure is defined as a method which limits the structural usefulness of the material of the structure up to a certain load at which the maximum stress in extreme fiber reaches the characteristic strength of material in bending. Define ultimate load design method. This method is otherwise known as load factor method or ultimate strength method. This method is based on the ultimate strength, when the design member would fail. In this method, factors are taken into account only on loads or load factors. The method of ultimate design of a structure is defined as a method which limits the structural usefulness of the material of the structure up to ultimate load. Define limit state method. The limit state method is defined as a method which limits the structural usefulness of the material of the structure up to a certain load at which acceptable limit of safety and serviceability are applied so that the failure of structure does not occur. It is the combination of working stress method and ultimate load method. In this method, partial factor of safety is considered on both loads and stresses. This method is advanced over other methods, since safety and serviceability are considered. Define characteristic load. A characteristic load is defined as that value of load which has a 95% probability of not being exceeded during the life of the structure. Equals plus times where F K equals characteristic load F M equals mean load K equals constant equals 2.645 2.65 S D equals standard deviation for the load. Define permissible stress. It is defined as the ratio of yield stress to the factor of safety. Equals H O. Define factor of safety. Factor of safety is a number used to determine the working stress. It is fixed based on the experimental works on the material. It accounts all uncertainties such as material defects, unforeseen loads, manufacturing defects, unskilled workmanship, temperature effects, etc. Factor of safety is a dimensionless number. It is defined as the ratio of ultimate stress to working stress for brittle materials or yield stress to working stress for ductile material. Equals. Define modular ratio. It is defined as the ratio of elastic modulus of steel to that of concrete. It is used to transform the composite section into an equivalent concrete section. Equals 280/3. What is the expression recommended by the IS 456-2000 for modulus of elasticity? Equals 5000 V. State the assumption made for design of reinforced cement members in working stress method. Refer IS 456:2000 page No. 80. In the methods based on elastic theory, the following assumptions shall be made. At any cross-section, plane sections before bending remain plane after bending. All tensile stresses are taken up by reinforcement and none by concrete, except as otherwise specifically permitted. The stress-strain relationship of steel and concrete, under working loads, is a straight line. The modular ratio M has the value 280/3. CBC. Where CBC is permissible compressive stress due to bending in concrete and N/mm2. What are the advantages in limit state method? Ultimate load method only deals with unsafety such as strength, overturning, and sliding, buckling, fatigue. Working stress method only deals with serviceability such as crack, vibration, deflection, etc. But, limit state method advances than other two methods. Hence, by considering safety at ultimate load and serviceability at working load, the process of stress redistribution and moment redistribution are considered in the analysis, and more realistic factor of safety values are used in the design. Hence, the design by limit state method is found to be more economical. The overall sizes of flexural members arrived by limit state method are less, and hence they provide better appearance to the structure. What are the advantages of working stress method? The design usually results in relatively large sections of structural members, compared to ultimate load. Due to this, structures designed by working stress method gives better serviceability performance under working loads. This method is only the method available when one has to investigate the reinforced concrete section for service stresses and for the serviceability state of deflection and cracking. What are the disadvantages of working stress method? The working stress method does not show the real strength nor gives the true factor of safety of the structure under failure. The modular ratio design results in larger percentage of compression steel than that given by the limit state design, thus leading to uneconomic design. Because of creep and nonlinear stress-strain relationship, concrete does not have definite modulus of elasticity. The working stress method fails to discriminate between different types of loads that act simultaneously but have different uncertainties. What are the advantages of ultimate load method? While the working stress method uses only the nearly linear part of stress-strain curve, the ultimate load method uses fully the actual stress-strain curve. The load factor gives the exact margin of safety against collapse. The method allows using different load factors for different types of loads and the combination thereof. The failure load computed by ultimate load method matches with the experimental results. The method is based on the ultimate strain as the failure criteria. The method utilizes the reserve of strength in the plastic region. What are the disadvantages of ultimate load method? The method does not take into consideration the serviceability criteria of deflection and cracking. The use of high-strength reinforcing steel and concrete results in increase of deflection and crack width. The method does not take into consideration the effects of creep and shrinkage. In the ultimate load method, the distribution of stress resultants at ultimate load is taken as the distribution at service loads magnified by the load factor. This is erroneous since significant redistribution of stress resultants takes place as the loading is increased from service loads to ultimate loads. What are the factors considered in limit state of collapse? Flexure, compression, shear, torsion. 24. What are the factors considered in limit state of serviceability? Cracking, deflection, durability, fire resistance, vibration. What are the factors of safety in limit state? Partial factor of safety for concrete equals 1.5. Partial factor of safety for steel equals 1.15. Partial factor of safety for load. Write down the value of partial safety factor for concrete and steel. Partial factor of safety for concrete equals 1.5. Partial factor of safety for steel equals 1.15. What is under reinforced section? Steel reaches maximum permissible stress earlier than concrete due to external loads is called under reinforced section. What is over reinforced section? Concrete reaches maximum permissible stress earlier than steel due to external load is called over reinforced section. What is balanced section? Concrete and steel reaches maximum permissible stress simultaneously due to external load is called balanced section. Define singly reinforced section. Steel reinforcements are provided only on tension zone of RC flexural member is known as singly reinforced section. Define doubly reinforced section. Steel reinforcements are provided on both tension and compression zone of reinforced concrete flexural member is known as doubly reinforced section. In some situations it becomes essential for a beam to carry bending moment more that it can resist as abalanced section. In this case additional reinforcement is provided in compression zone. Such beams reinforced in both compression and tension zones are known as doubly reinforced section. Under what circumstances doubly reinforced beams resorted to? When then doubly reinforcement is used. Write down the basic values of span to effective depth ratio for the different types of beam. Basic values of span to effective depth ratios for spans up to 10 meter. Define collapse state. The limit state of collapse of the structure or part of the structure could be assessed from replace of one or more critical sections and from bulking due to elastic or plastic instability or overturning. Cantilever. 7 simply supported. 20 continuous. 26. Define the terms gross section, transformed section, cracked section. Refer is 456:2000 page No. 35. Relative stiffness. The relative stiffness of the members may be based on the moment of inertia of the section determined on the basis of any one of the following definitions. A. Gross section, the cross section of the member ignoring reinforcement. B. Transformed section, the concrete cross section plus the area of reinforcement transformed on the basis of modular ratio. C. Cracked section. The area of concrete in compression plus the area of reinforcement transformed on the basis of modular ratio. Draw the stress-strain curve for concrete, mild steel bars and HYSD bars. See figure. Define brittle and ductile failure. Materials that fracture without any plastic deformation are called brittle materials. Example: glass and other ceramic materials. Materials undergo plastic deformation before fracture is called ductile material. Example: aluminum, copper, steel, and many metals, as well as polyethylene, nylon, and many other polymers. Define clear cover. The distance between the bottom of the bars and bottommost edge of the beam is called clear cover. Define effective cover. The distance between the center of the reinforcement bar and the bottom edge of the beam is called effective cover. Equals. Plus. 2. What do you understand by development length of bar? The reinforced bar must extend in the anchorage zone of concrete sufficiently to develop the required stress. The extended length of bar inside the face of the support is known as development length. It is denoted by the symbol L. D. Define anchorage length. Anchorage length is defined as embedded portion of the bar in concrete, but not subjected to any flexural bond. Define anchorage bond. All the types of reinforcement must be anchored within the concrete section, in order that the anchorage bond should be sufficient to develop the stress in the bar. The anchorage depends on the bond between the bar and concrete and the area of contact. Define curtailment of bars. In flexural members, design of reinforcement is done based on bending moment along the span. As the magnitude of bending moment on a beam decreases along its length, that case the area of bending reinforcement may be reduced by curtailing bars as they are no longer required. What do you mean by equilibrium torsion? Torsion induced by eccentric loading and equilibrium condition alone sufficient to determine twisting moments is known as equilibrium torsion. Define torsion. Equal and opposite moments applied at both ends of structural element or its part about its longitudinal axis is called torsion. It is also called as torsional moment or twist or torque. What is compatibility torsion? Torsion induced by application of an angle of twist and the resulting moment depends on the torsional stiffness of the member is known as compatibility torsion. How can torsional resistance of RC members be enhanced? Increasing strength of concrete and the amount of longitudinal as well as transverse reinforcements over and above those required for bending and shear can enhance the torsional resistance of a member. Name the locations in beam where the development lengths of torsion bars should be checked. At beams, development lengths should be checked at the sections where maximum bending moment occurs. Point of curtailment. Point of inflation. Write down the effect of torsion in reinforced concrete beams. Reinforced concrete members may be subjected to torsion in combination with bending and shear. Longitudinal and transverse reinforcement shall be provided for reinforced concrete beams to resist torsion. Torsional reinforcement is not calculated separately from that required for bending and shear. Instead, the total longitudinal reinforcement is determined for a fictitious bending moment which is a function of actual bending moment and torsion. Write about local bond and anchorage length. All types of reinforcement must be anchored within the concrete section, in order that the anchorage bond should be sufficient to develop the stress in the bar. Anchorage length is defined as embedded portion of the bar in concrete, but not subjected to any flexural bond. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.